Okay, this first video is the free response corrections video that has a bow and arrow on it. So if that's the test you have, then this is the video you want to watch. Okay, let me get this all centered correctly. Focus my camera a little bit better, maybe. There we go. Okay, so Will Tell is shooting at an apple that hangs on a tree. The apple is a horizontal distance of 20 meters away. Underline that. Horizontal distance of 20 meters away and at a height of 4 meters above the ground. The arrow is released from a height of 1 meter above the ground and hits the apple 0.5 seconds later. I have to find out what the initial horizontal velocity is, so I'm looking for Vx naught. I'm going to put that right here. I have to find out what the initial vertical velocity is, so I'm looking for Vy naught. And then I have to find out what the initial velocity is with respect to the horizontal, so I'm just looking for V naught. Okay, D, I have to sketch a graph for horizontal velocity as a function of time, so Vx as a function of time. And then E, I have to sketch a vertical velocity as a function of time. Okay, so to start out with, here are the things I know. X naught is 0 and X is 20. The horizontal distance is 20 meters. Y naught is 0, so if we call this 0 right here, vertically, it climbs up 3 more meters to get to the apple because it started 1 meter above the ground. So it actually only had to climb 3 meters to get to the apple. So y equals 3. If we're calling y naught 0, y equals 3. 3 meters above y naught. The vertical acceleration is negative 10 meters per second squared. I'm looking for Vx naught and Vy naught. And I also know that the arrow hits the apple 0.5 seconds later. Okay? So to get Vx naught, or maybe I should say x is equal to Vx naught times t. If I rearrange this for Vx naught, I get x divided by t. So that's simple enough. I already know x is 20 meters. The time is 0.5 seconds. So Vx naught equals 40 meters per second. And it remains 40 throughout the entire time because there's no horizontal acceleration. Okay, so for B, to get Vy naught. This one was a little tougher, but I had to find an equation that I knew everything in it except for Vy naught. And looking at the second equation, using all y's instead of x's, I know y, I know y naught. Looking for Vy naught, I know time. I know acceleration, I know time. So I know everything in this equation except for Vy naught. So in rearranging this equation, I'm going to slip another sheet of paper here. In rearranging this equation, this segment's gone because it's 0. And I want to get this segment by itself. This has the unknown in it, so I want to get it by itself to begin with. So I'm going to subtract this segment from both sides. When I subtract it from both sides, I've got y minus 1/2 at squared equals Vy naught times t. Okay? Now I want to get Vy by itself, or sorry, Vy naught. I want to get the initial vertical velocity by itself now. I only have multiplication, so the opposite of multiplication here is division. So I'll divide both sides by t. So now I have that Vy naught is equal to y minus 1/2 at squared, all divided by t. Can this cancel this out? If you don't know for sure, you need to leave it there. The answer is no, it can't cancel it out because of the subtraction. But if you're not for sure, you should always leave it there. Okay, so this is the equation I'm going to follow. It's written right here. In my calculator, I'll plug in parentheses around the top portion because there's a subtraction sign. So I want to make sure to divide the answer to this by t. So parentheses open, 3 minus 0.5 times negative 10 times 0.5 squared. This 0.5 refers to the 1/2. This 0.5 refers to the time, and we're squaring it. Okay? And I put parentheses around these. I don't have to do an extra set of parentheses because inside of this parentheses, my calculator will do multiplication before it does subtraction. Order of operations. Okay, and then I hit the divided by for the slash, and then the time again is 0.5 seconds. So I plug this into my calculator. Everything's in meters and seconds, so everything cancels out appropriately, and I get 8.5 meters per second. So that's my Vy naught. Okay, so now I know my Vx naught, and I know my Vy naught. And now I'm asked to find V naught. V naught is this velocity right here. And so this V naught has a horizontal component to it and a vertical component to it, which I already have. I have my Vx naught and I have my Vy naught. So I just make this triangle, Vx naught horizontally, Vy naught vertically, connect it with a dotted line. Oops, I'm sorry, I'm not showing it to you. Let me re-say that. Vx naught horizontally, Vy naught vertically, connect it with a dotted line. Pythagorean theorem, square root of 40 squared plus 8.5 squared, parentheses closed, gives me 40.9 for the magnitude of the velocity. And then I've got to get the angle. So remember, you've always got to go back to the tail of the first vector. You want to get this angle. And so I'm going to hit second tan because I'm looking for the angle. So I use the second tan. Second tan, parentheses open. The opposite side of the angle is 8.5. The adjacent side to the angle is 40. This is also adjacent, but it's the hypotenuse. So this is the hypotenuse, this is the opposite, this is the adjacent. So when I plug this in, I get 12 degrees. That is 12 degrees with the horizontal. And the question is, find the initial velocity with respect to the horizontal. It's 12 degrees. Okay, so I've got A, B, and C. D, I have to sketch a velocity time graph in reference to horizontal velocity. Since there's no acceleration or deceleration horizontally, my horizontal velocity stays constant. E, I had to sketch a vertical velocity as a function of time. And vertically, you can see my velocity is positive. But what happens up here? My velocity is positive here, and it goes up until it hits 0, no vertical velocity, and then it starts going back down again and speeding up while it goes down. So remember, anything, any projectile, anything in free fall, it always has a constant negative acceleration of negative 10 to be exact. So I start with a positive vertical velocity, and it slows down to 0, and then it starts speeding back up in the opposite direction. This is a constant negative slope, so that would be a constant negative acceleration. Okay, be sure and watch the other correction video if you want to just go over it and help yourself out on the test, just a double study. Good luck.